Alright, 1.6. Determine a quadratic equation given its roots. What we need to be able to do is look at the zeros. And if we look at the zeros and we're given those zeros, we can find the equation of a quadratic function within a certain family that share the same x-intercepts. Now, if we want a specific equation, we need to be able to have another point on that quadratic to determine a specific equation that matches that particular quadratic. So one more time. The zeros can be used to find the equation of a family of quadratic functions with the same x-intercepts. When a family, we're talking about, they could be opening up, they could be opening down. It could be a very thin parabola or very shallow and wide parabola. But the idea is that this is all a family because they share the same x-intercepts. Now, if we were to determine an individual quadratic function, you would not only just need the zeros, but you would also need to be given one other point on the function. And remember that there are different forms of quadratic equations that you can use. There is the vertex form, y equals a, x minus h all squared plus k. There is the factored form, which is the roots form, and the roots are y equals a times x minus r in one set of brackets and x minus s in the other set of brackets. So this is the factored form, or the roots form, r representing one of the roots and s representing the other root, or zeros. And finally, there is the standard form, y equals ax squared plus bx plus c. The standard form, sometimes you will need to be able to express your final answer in standard form. Moving on. Example 1. Write the equation of a quadratic function whose only x-intercept is 5 and passes through -1, -8. What is this saying? Well, if you have a quadratic that has only one x-intercept, you should remember from the previous lesson that that means that the x-intercept, being only one of them, would also end up being the vertex as well. So in this case, you're given one x-intercept, and that's 5. So 5, 0 is our vertex, and we're given another point. So we will use the vertex form to find the equation. That is, we want to be able to plug in 5, 0 for h and k, and -1, -8 for x and y into the vertex form of a parabola. Plug in the values. Y will be -8 equals a, which remains a because that's what we're looking for. X is -1 minus h, which is 5, all squared, plus k, which is plus 0. And now we solve for a, and we end up with -8 is equal to 36a. That means a is equal to -2/9. When we divide both sides by 36, it will reduce to -2/9. So that is my a value. So my equation will end up being y equals -2/9 x minus 5 all squared plus 0. So we don't put the plus 0. So this, folks, is the equation of the parabola in vertex form. We can give it in any form. All right, moving on. What if you have a question that asks for a family that has roots at x equals -1/2 and x equals -4? Well, when you're asking for a family, you're not looking for a specific a value. So the a remains a. So we sub r is equal to -1/2 and s equals -4 into the roots equation, because these are two roots that were given. And we get the equation y equals a x plus 1/2 times x plus 4. Now, this cannot remain the way it is, because when we actually simplify this, there should be no fractions. So we need to expand this out. If you think about it, it's just multiplying that bracket by 2. So we have 2x plus 1, and then we have x plus 4. So we're multiplying it by 2 to be able to expand this first set of brackets. Okay, so this represents a family of equations, varying a values, that has a root at x equals -1/2 and x equals -4. Next, what about x-intercepts at -2 and 4 and passes through a certain point? Find the equation in vertex form. What about this type of question? Well, we sub the r value for -2, s value for 4, because we're given two roots, so we must use the roots form of equation. And we use the point for x, y. And we sub that into the roots formula. So, our y value is 3, a value is a, x is -1, minus -2 means plus 2, x again is -1, minus 4, and now we find the value, the coefficient for a, which will be 3 is equal to a times -5. So our a value will end up being -3/5. So our equation is -3/5, x plus 2 times x minus 4. Now the reason we're not done yet is that we need the equation in vertex form. So how do we do that? Well, there are different ways that we can approach this. One way is we can expand the equation and complete the square. So we would expand the equation to standard form, and we would complete the square at that point. When we complete the square, let's go over the process. When you complete the square, you take out the a value from anything where there's a variable. So we have -3/5 bracket x squared minus 2x plus 24/5 is on the outside. Next step, -3/5. We need to take this number and divide it by 2. So we have x minus 1 all squared minus minus 1 squared times -3/5 plus 24/5. And another way to think about this is to memorize how to complete the square using a formula. That is a bracket x minus b/2a all squared minus b/2a all squared times the a value plus c. And that, folks, is the formula in order to complete the square. And that's exactly how we got these values. So we have -3/5 times x minus 1 all squared plus 27/5. This now is in vertex form. Is there another way that we could do this? Yes, there is, folks. Let's look at another way that we could have gotten vertex form without having to expand and then complete the square. So let's go over and recap. We were given that r is equal to -2 and s is equal to 4. We can find the h value by adding the r and the s and dividing by 2. So we can determine the h value. The h value is the x value of the vertex. So I'm writing this out, x value of the vertex, and it is also the axis of symmetry. The axis of symmetry is found by finding two zeros, adding them up, and dividing by 2. That will give you the x value of the vertex as well as the h value for the vertex. The x value of the vertex, which is the h in the equation of vertex form. So I'm going to take -2 plus 4 divided by 2 and I get 1. That is the same number that we got earlier. Now, in order to find the k value, we have to sub. What are we subbing? So we now need to find the k value of the vertex. So the k, which is the y value of the vertex. And to do that, we sub h equals 1, a equals -3/5, which we had found earlier, -1,3 for the point xy into the vertex form of the equation. This will allow us, once we plug in h, a, x, and y, this will allow us to find k. So that means that it will be 3, which is y, equals a, which is -3/5, times x, which is -1, minus 1, all squared, plus k. K is what we're looking for. You'll find out that 3 is equal to -3/5 times -2 all squared plus k. That is 3 is equal to -12/5 plus k. That means k is equal to 27/5. Wow! So now we have the y value of the vertex and we can do the equation in vertex form, which is y equals -3/5 x times x minus 1 all squared. Remember, that was our h value up here. X minus 1 all squared plus 27/5, which we just found as our k value. And if you look from the previous slide, you will see that we got the exact same equation doing it a different way. Both ways are acceptable. Okay, moving on. What happens if you're given the zeros in exact form, but they're radicals? How do we find the equation of a quadratic that has radical zeros? Well, folks, it is possible to find it, but you need to do this step by step. That is, sub 2 plus or minus √5 for r and s, 2 plus √5 for r, 2 minus √5 for s, and 1 -12 for xy. Into the equation y equals a, x minus r times x minus s. And that is because we're given two roots. We plug it in and we get -12 is equal to a times 1 minus 2 plus √5 times 1 minus 2 minus √5. We simplify inside those brackets and we get -12 is equal to a times 1 minus 2 minus √5, 1 minus 2 plus √5, and simplify again, and we get -1 minus √5 and -1 plus √5. Now the key to the next step is to expand this properly. When we expand this, use FOIL, and you will see a magic number appear. -1 times -1 is +1. -1 times plus root 5 is going to be negative root 5. Negative root 5 times -1 is going to be plus root 5. And negative root 5 times positive root 5 is going to be negative root 25, which square root of 25 is just 5. But what you should see is magically these roots disappear. So you will end up with 1 minus 5. Because when you expand it, it looks like, if you notice, a difference of squares. And because it looks like a factored difference of squares, this will allow the middle term to disappear on us. So that we have 1 minus 5, which is -4. -4 gets divided over to the other side, and -12 divided by -4 is just +3. So my A value is +3. Now what we have to do is find the equation. An equation in standard form. That is, sub A is equal to 3, R is equal to 2 plus root 5, S is equal to 2 minus root 5, into the equation y equals A, x minus R times x minus S. So we have our 3, we have our R and our S, and what we have to do is expand this. When we expand it, we're going to use something called, again, that difference of squares property, but with x minus 2 as the front and root 5 is the end. The plus or minus is this part that gets changed. And what we end up with is 3x minus 2 all squared minus root 5 all squared, which can be expanded to be as follows. X minus 2 times x minus 2, and then you subtract 5. When you expand this all out, will give you y equals 3x squared minus 12x minus 3. If you're to expand it the long way, I can show you the long way in blue here. And you will still end up with the exact same answer of y equals 3x squared minus 12x minus 3. Is there another way to do this? And folks, of course there is. Let's look at another way to be able to get this answer, but maybe with a simpler explanation. Remember that A is equal to 3, R is equal to 2 plus root 5, and S is equal to 2 minus root 5. We also know that there's a point at 1, -12. How does that help us? Well, if we find the H value first, so the vertex part, that will help us. The H value of the vertex, that could help us find the vertex. Once we find the vertex, we're able to actually find the equation by expanding the vertex form. And that will eliminate the need for using the root values. So one more time, find the H value by taking R plus S divided by 2. When I do that, I find out that my H value is just 2. Now, we sub the H value of 2, the A value which we found out, and, okay, that might be a little too fast. Let's move a little bit backwards. A value is 3. Our coordinates 1, -12 for x and y into the vertex form to find K. Once we plug it in, so -12 is equal to 3, which is our A, times x, which is 1, minus h, which is 2, all squared, plus k. Once we plug it in, we can find the k value. 1 minus 2 is -1 squared, is 1. So we have -12 is equal to 3 plus k. That means k is equal to -15. Because we have our h and our k, we can use the vertex form and then expand that. What that will help us is to eliminate the need to expand with roots. The hardest part about this is that it actually takes longer to get the answer. But again, we get the same answer, y equals 3x squared minus 12x minus 3, as we did when we expanded with roots. 3x squared minus 12x minus 3. Okay, moving on. What about finding the equation of a graph? So here is a graph of a parabola. Which equation can we use? Well, we're given the possibility of using two equations. One being where we know the zeros and any other point on the graph to be able to find the equation. Another way to do this is we have the vertex. And because we know the vertex, we can use any other point and the vertex to find the equation in vertex form. So let's try this. That is, using the zeros and, in this case, the y-intercept, we will find the equation of this parabola. Sub r equals -1, s equals 3, those are our roots, and 0, -6 for xy in the equation y equals a, x minus r, x minus s. Plug in the values, and you get that -6 is equal to -3a. That means a is equal to 2. So our equation is y equals 2, x plus 1 times x minus 3. Something else you can see is another way to do this problem. So let's erase this and see it another way. Now don't forget, this is the answer. Let's see another way. What happens? Well, when I expand this, note, will be y equals 2x squared. Let's just check that for a second. Y equals 2x squared minus 4x minus 6. That's the expanded version of this factored form. This will be important when we show the other way that you could have gotten the equation. So whether it's in standard form, factored form, or in vertex form, you will have the same equation. So here we go. If we sub the vertex 1, -8 for h and k, and a point, which point are we going to use? Well, you guys can use any one of the zeros, or you can use even the y-intercept. In this case, we're using the y-intercept for x and y into the equation in vertex form. Once we plug it into vertex form, I get y, which is -6, is equal to a times 0 minus 1 all squared minus 8. That's our k value. We solve. -6 is equal to 1a minus 8. That means we move the -8 to the other side. It becomes +8. -6 plus 8 is 2, is equal to a. So now we found the a value, which was the same a value we found earlier. Our equation is going to be y is equal to 2 bracket x minus 1 squared minus 8. Now remember we had the expanded form. Let's see if we expand this, do we get the exact same answer? So what we will have here, let's expand it, I'll do it in blue. Y is equal to 2 bracket, and we expand x minus 1 all squared to be x squared minus 2x plus 1, and then minus 8. We expand out the 2. We get 2x squared minus 4x. We have to multiply that too. So minus 4x plus 2 minus 8. Our final answer will be y equals 2x squared minus 4x minus 6. And lo and behold, folks, that matches the equation we found earlier. So again, In this type of question, it doesn't say what form to do, so you can use any one of the forms given. Moving on. Let's talk about a square flower garden. That is, when we talk about that, a square flower garden is surrounded by a brick walkway that is 1.5 meters wide. The area of the walkway is equal to the area of the garden. Determine the dimensions of the flower garden to the nearest tenth of a meter. Well, folks, we're going to have to draw this out. That is, here's a square garden and a walkway that goes around the square garden. This walkway is 1.5 meters wide. Doesn't matter where we measure it from, it is always 1.5 meters wide. And we know, given the problem, that the area of the walkway is equal to the area of the garden. Now, what is the area of the garden? Well, we have to let x represent the width of that garden. Because it's a square, it means the width is the same all the way around. So the area of the garden is going to be x squared. The area of the walkway is going to be the whole thing, which you have to think about how big is this one whole side, which will be the same width as this whole side. And once we know the whole thing, we can subtract out the garden to know just the area of the walkway. That is, how much is the width of that entire garden plus walkway? Well, we know this piece here is x. We know this piece here is 1.5, and we know this piece is 1.5. So the entire width of the garden and the walkway together is going to be x plus 3, 1.5 times 2. And so it's x plus 3 all along the area of the walkway on the outside. So x plus 3. So we need to know just the area of the green walkway, not the garden. Well, we have to take the area of the walkway and the garden put together, which is x plus 3 all squared, or x plus 3 times x plus 3, and we have to subtract the garden, the x squared. What that will give us is x squared plus 6x plus 9 minus x squared is equal to x squared. Collecting like terms will give us 6x plus 9 is equal to x squared. Move everything to the side where x squared is positive. We will get 0 equals x squared minus 6x minus 9. Now, if you try to figure out what two numbers multiply to give you negative 9 and add to give you negative 6, you will discover very quickly that it is impossible for that to be true. Therefore, we need to use the quadratic formula to solve this problem. So, here is our a, b, and c, and our equation. X equals negative b, so b is negative 6, negative 6 is positive 6, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a times c, all over 2a. So when I plug that in, I will get the discriminant first, because remember, whenever we use the quadratic, you need to show the discriminant first, and you will get x is equal to 6 plus or minus the square root of 72, all over 2. As a result, when you simplify that, when you add it, that will give you a number of 6 plus or minus the square root of 36 times 2 in the underneath the root sign, all over 2. And you simplify again. Square root of 36 is 6. That comes outside, and we divide each piece by 2. You will get 3 plus or minus 3 root 2. So, adding gives you this decimal, and subtracting gives you this decimal. Let's talk about these answers. Which one of these is valid? Well, folks, you can't have negative width. So that is not feasible. So the only possible answer for X, the width of the garden, is 7.2 meters. So therefore, the dimensions of the flower garden to the nearest tenth of a meter is 7.2 meters. And now you would just write the therefore statement to answer that. Because remember, if you start with words, you should end with words. So therefore, the width of the garden to the nearest tenth is 7.2 meters. Well, that's the end of the video, folks. Have a numerical day.